right, today we are going to talk about section 6.5. This is our second to last section for this chapter. We will talk about 6.6 next week. Today we are going to use properties of trapezoids, but first our warm-ups. Find the coordinates of the midpoint of segment AB. Who remembers how to find a midpoint? What do we need to do with those numbers? You're on the right, almost the right track, kind of. Not quite. So the midpoint is in the middle, right? It's kind of like taking the average. If I'm taking the average of some numbers, how do I do that? What do I have to do with the numbers before I divide? No. Yes, but what do I do with numbers when I'm trying to find the average? If I was trying to find the class average of the last quiz. Okay, so we add together, divide by how many numbers there were. So if I'm trying to find the average of my x coordinates, because that would give me the middle of them, I'm going to add my x coordinates together and divide by what? 2, because there are 2 coordinates. So x1 plus x2 divided by 2. And then I have to do the same thing with my y's. Average of the x's, average of the y's. This is midpoint for those of you that needed to put that back in your notes. It has been a while since we've done it. Okay, so to find the midpoint on number 1, for my x's, I need to add what? 0 plus 4 is 4. Then we divide it by 4 divided by 2 is 2. For the y's, what am I adding? Okay, 0 plus negative 2 is negative 2. Then we divide by 2. Negative 2 divided by 2 is negative 1. That's all there is to it. So on number 2, when we're finding the midpoint, for our x's, what are we adding together? Okay, 3 plus negative 7 gets divided by 2. What about for the y's? Okay, gets divided by 2 again. So what is 3 plus negative 7? Negative 4 divided by 2 is negative 2. Negative 5 plus negative 1? Negative 6 divided by 2 is negative 3. Questions, concerns about finding midpoint? All right, on 3 and 4, we are solving for y. There are a few different ways you could do these. What is your instinct to do first on number 3? So distribute would be one option. Or you could multiply both sides by something that would get rid of this fraction, which would be 2. So you could either distribute the 1/2, or you could multiply both sides by 2. What do you want to do?
Multiply both sides by 2.
Okay. Multiplying both sides by 2, I think, does make it a little easier, a little quicker, as long as you do it correctly. Oh, sorry, wrong problem. I mean, we can do it on that one as well, but we'll start with this one. There we go. Okay, so if I multiply 25 times 2, what do I get? 25 times 2. 50, okay. Equals, what happens to the 2 and the 1/2? They cancel each other out totally, so they're both all used up. So what do we have left? 16 plus y. And so the only thing we have left to do is subtract. What do we get for y? 34 is our y. Questions, concerns about number 3? Okay, now you could have gotten there by distributing the 1/2, subtracting the 8, and then multiplying both sides by 2 at the very end. But I think it makes it a little cleaner to do it in the beginning. On 4, we are going to do the same thing. Multiply both sides by 2. 2 times 26 is 52. Remember, the 2 and the 1/2 cancel out, so now there's nothing that we need to distribute, so we can drop those parentheses. And our last thing is to subtract 47 on both sides. We're running out of space. What do we get for y?
5.
Y equals 5. Questions, concerns about our warm-ups? Okay. Need more time? On we go. All right, so today is all about trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. If there is only one pair of parallel sides, is it a parallelogram? No, because in a parallelogram, we have to have both pairs of opposite sides parallel. I'll give you a minute to write some of this down before we start labeling our diagram. All right. So we have a quadrilateral, which means it has how many sides? 4 of them, 4 sides. One pair of parallel sides. Now, from the way that this is drawn, which pair looks like they are the parallel ones? Top and bottom, so I'll go ahead and mark that. Generally, you should have parallel ones marked. It's possible they won't mark them on trapezoids. If you're told it's a trapezoid, you would kind of assume that one pair is parallel. So the legs are the non-parallel sides. Where do we see those in this diagram? On the sides, the left and the right. So this over here would be a leg. Let me try to write sideways. This is a leg. Over here is a leg. The bases are the parallel ones. So we have a base on top and a base on bottom. Now keep in mind that it's not necessarily always going to be the top and the bottom that are the bases. It's just going to be the ones that are parallel. So if we were to take this whole thing and turn it 90 degrees so it sits on its side, then the bases are on the left and the right instead of the top and the bottom. The median is the segment that joins the midpoints of the legs. So if I were to put my midpoints on my legs and then connect them, that segment is the median. I would know for sure that that is the median or that these points are midpoints if my leg pieces are marked as congruent to each other. So we could put some tick marks in there. The entire legs are not necessarily congruent to each other in this case. But when I put the midpoints on there, each leg is split into two congruent pieces. We can find the length of a median in a trapezoid if we know the lengths of both bases. So we add the bases together, so that's the length of the parallel sides. Add those together and multiply it by 1/2, or you could consider it dividing by 2. Base plus base, the whole thing divided by 2. That's a different way of writing the same thing. Bless you. The property there is a little hard to read with the icon in the way. The median is parallel to the bases. So I could also put one little parallel triangle on the median, because that median also needs to be parallel to the bases. All right, an isosceles trapezoid is just a trapezoid with congruent legs. So the ones that are not parallel are congruent. And it's got a few properties that we'll talk about. I'll give you a minute to write them down before we talk about them and label a picture. We were told that this would be a trapezoid with congruent legs. So I went ahead and marked my parallel sides, which would be my bases, and my legs as being congruent on the sides. So first property, the lower base angles are congruent. The wording on that is not my favorite, because if we were to turn this whole diagram 90 degrees clockwise or counterclockwise, the base angles would no longer really be upper or lower. So just keep that in mind. But the two angles along a base are going to be congruent to each other. So in this case, that would be angles A and D. The upper base angles are congruent. Again, the word upper might not make sense if we were to turn the diagram. But for the way this one's set up, B and C are congruent to each other. Questions so far about those? The diagonals are congruent, so I don't know that I want to draw those in because that'll break up my angles. But based on the way that I labeled this diagram, what would the diagonals be called? What are those segment names? Good. AC would be congruent to BD. You could draw them in, but it's going to be hard to draw them in and mark them congruent and not mess with the way your angles look already. Either lower base angle is supplementary to either upper base angle. There is a reason for that. Okay, we have parallel lines. They're cut by a transversal on the side, which makes an upper and lower base angle pair consecutive interior angles, which we learned back in chapter 3 would be supplementary. Supplementary means that they add up to 180. So this is an idea that we're going to have to use. So one example of that would be to say the measure of angle A plus the measure of angle C, it doesn't have to be the one right next to it this time, it could be the one over here, would equal 180 degrees. We could make more statements like that. Okay, we could do angles A and B are 180, D and C are 180, D and B are 180. Okay, so just mix and match your upper and lower base angles. Questions, concerns, need more time on this slide? Alrighty then, let's get to our examples on the back. I will label this trapezoid for us real quick. We've got L, M, N, P. as our trapezoid. And I'll go ahead and put a median in there. And mark our parallel sides, our bases. All right. What's one of the bases of this trapezoid? LM is one of them. What's the other one? PN. Good. The parallel ones are the bases. What's one of the legs? Okay, it's got to be PL. So I heard a few different answers. PL is the whole leg. So we don't just want part of it. We want the whole thing. PL is one of them. What's the other? MN. Okay, the base angles, I think that's a little misleading to say generically base angles. So let's pair them up. So give me a pair of base angles that would go together. P and N would be a pair. Angle P and angle N is a pair of base angles. They're on the same base. P and N share a same base. And what's the other pair? Okay, angle L and angle M would be the other pair because they're on the same base. What is our median? QR. So QR is the median. I knew that it was the median because I marked the pieces of my legs congruent to each other. So I knew that Q and R were both midpoints. Oop, should be segment QR. There we go. Questions, concerns, need more time with example 1. Should be pretty straightforward, I hope. Okay. Okay, so we've got a trapezoid with some information given, some information we're looking for. What is the length of WX? 3. How'd you know that? Okay, so if TX is a median, we know that because UX and XW were marked as congruent, then each of those has to be the same and they need to add up to 6, so 3 is correct. In order to find TX is the median, so that's when we have to use the 1/2 base 1 plus base 2. What are the measures of the bases? 20 and 10. 20 plus 10 is, half of that is 15, so 15 would be our length for TX. Questions about finding that? Okay. Now, because they marked, or we marked, I marked, each little piece of each leg as being the same, that means this is an isosceles trapezoid. Does that make sense? Okay, if these two are both 3, so the whole thing's 6, and these are marked with 1 tick mark also, these are both 3, so the whole thing's 6. That means our legs are congruent, so it is isosceles. We following my logic here? If that weren't the case, it would make it hard, maybe impossible, to do some of these other angles. I think we could definitely find 1, but it would be harder to know angles U and 2. Okay, so since it is an isosceles trapezoid, it has more properties. One of them is that the base angles are congruent. So angle U has to be what? 80. U and 80 are on the same base. Even though it's turned a little bit. We see that? The one that was marked with 80 degrees and the angle at U are on the same base, so they would have to be congruent. What about the measure of angle 1? That one would be 100 degrees. Okay, the one we were given with the 80 and angle 1 are not on the same base. They're on different bases. So they have to be supplementary to each other. What about angle 2? Why? Good. 1 and 2 are on the same base, so if it's an isosceles trapezoid, they need to be the same. Questions, concerns, need more time? We're sure? Okay. Now, don't get too caught up in the whole congruent angles thing. That does not always happen. For instance, you could have a trapezoid that's set up like this. Okay, so in this case, I hope it's obvious that your base angles, one of them is a right angle, and this angle down here at A is obviously not a right angle, right? The base angles are not always going to be the same. That's special for isosceles trapezoids only. Get what I'm saying? Okay, so don't always make the assumption, oh, they're on the same base, they're the same. That's only true if it's marked isosceles or you're told it's isosceles. Ready for the next one? Now, this problem has always confused me, but I didn't create this, so I'm just going with it. Why do you think it confuses me that this one's in here? It's a triangle. Now, maybe that's the point. Make sure that you're staying on your toes here. But this is just a good old-fashioned triangle, so really, we don't need all of our trapezoid rules to do this. What kind of triangle is this? Okay, good. I heard a couple correct answers. It is isosceles. It is a 45, 45, 90 because it's isosceles. Those are both 12s. Same. And it's right. So an isosceles right triangle is going to be a 45, 45, 90. Are we all good with why angles 1 and 2 both have to be 45s? Okay, these have to be congruent angles. All three angles have to add up to 180, so the only option is for them to both be 45s. So does anybody remember what that means for YZ? 12 root 2, very good. We could have gone old school and used our Pythagorean theorem, but once upon a time, we talked about the fact that the hypotenuse is equal to a leg times the square root of 2. So if we remember that, then that's helpful. Questions, concerns, need more time on example 3. Okay. Then let's talk about example 4. Is this an isosceles trapezoid? No. How do we know it's not an isosceles trapezoid? Okay, good. So this side, they each only have one tick mark, so those are congruent to each other, as they should be if this is a median through the middle here. But these have 2 tick marks. So that means that the legs are not necessarily congruent to each other. Okay, they're split into congruent pieces on their own, but all together, the legs are not congruent to each other. Let's start with finding EF, which is actually one of our bases. If I show my little parallel triangles there. You can put one on the median as well. Now, on the front page of our notes, we learned that the median is equal to half of the sum of our bases. But this time they gave us the median. What was the length of the median? 10. What's one of our bases? 16. And the other base is the one we're trying to find. Are we all good with how I plugged into that formula we had on the front? Okay, so we're trying to find this other base, which is EF. What should I do? Okay, this is similar to the warm-up, so that's why it was in there. We multiply both sides by 2. We get 20 is equal to 16 plus b. Then we would subtract, and what do we get for b? 4, so that is the length of our other base, EF. Obviously, this diagram is not drawn to scale, but that's fine. We don't go based on what it looks like, we go based on what it's labeled. All right, now the fun stuff with the angles. So first, I want to address angle 4 real quick. We're not going to find it just yet, but I want to talk about it. Is angle 4 going to be 110 degrees? No, why not? This is not an isosceles trapezoid. Are angles 1 and 2 going to be congruent? Not necessarily. Probably not, because this is not an isosceles trapezoid. Okay, I'm making a big deal about this because this is an easy kind of trap that people fall into. It's easier for us if those are already congruent. They're not, unless it's isosceles. Okay, but we do have a way of finding these angles, so let's first talk about angle 1. If we were to ignore a lot of what's going on here, and I'm just going to highlight the fact that we've got a parallel line on the top and the bottom, and this transversal cutting it on the side here. Angle 1 down at the bottom and the 110 degrees are still considered consecutive interior angles. Can we see it? Okay, if you ignore everything else, those two are on parallel lines. They're consecutive interior angles, so they do need to add up to what? 180. That does not mean that we could mix match angle 1 with angle 4 and do that. Okay, but in any trapezoid, you are going to have some consecutive interior angles that are supplementary. So what is the measure of angle 1? 70 degrees. Questions about that? Okay, similarly, we did learn a property that the median is parallel to our bases. So now I'm kind of switching my focus to only look at the median in my top base and that transversal. And again, angle 3 and the 110 are consecutive interior angles. So angle 3 would be 70 degrees as well. If instead of looking at the top base, you had looked at the bottom base, then angles 1 and 3, what relationship do they have? It's another C word. Corresponding, and corresponding angles are congruent on parallel lines. So either way you look at it, angle 3 has to be 70. Questions, concerns? Okay, so when we switch our focus and start looking at the angles on the other side of our trapezoid, which two angles have to be congruent? Well, there are a few ways we could go about doing this. Probably the easiest angle to find is going to be angle 5, in my opinion. just by looking at it. What do I know about the angle that I'm given in angle 5? They make up a straight line. You see that? This one that I labeled with a 60 and angle 5 together are a linear pair. They make up a straight line. So what does that mean about angle 5? It's what? It's 120. Okay, linear pairs are supplementary. Have to add up to 180 if they make a straight line. So now if we switch and start looking at angle 2, for example. If I highlight the median and the base at the bottom and this transversal here, we've got a few different relationships going on. We should know there's a relationship between angles 2 and 5. They're consecutive interior. Or we should be able to see that 2 and the angle that's marked with 60 are corresponding. Either way, what's the measure of angle 2 going to be? 60. Do we see it? Now it can be a little hard when these diagrams start getting busy. Anybody have any thoughts about what angle 4 is going to be then? 120. So if we pick two bases to look at, we could look at these two bases with our transversal on the side. 4 and 5 are corresponding angles. So that means angle 4 has to be 120 as well. Or 4 and 2 would be consecutive interior. 4 and 60 are consecutive interior. You have options about which bases you focus on or which parallel lines, the bases or the median. Do we have questions about number 4? That one gets a little tricky. Okay. I actually switched up the last example a little bit because I wanted to be able to talk about when we have variables involved. So you can kind of ignore the whole 1, 2, 3, 4, 5, EF, FM, EK off to the side and just label the trapezoid this way. Is this an isosceles trapezoid? Yes, they marked the legs congruent. We're not even involving the median this time, so we're not even worried about it. One of these angles should be really easy to know right away if this is an isosceles trapezoid. Which variable do we know basically right away? What's x? It's got to be 60. If this is isosceles, angles that are on the same base are going to be congruent, so x has to equal 60. That means that 3y has to equal what? 120, and y would then equal 40. Okay, having an isosceles trapezoid makes that a little bit nicer for us. Questions, concerns? Nothing?